All right, piecewise functions. Sometimes a functions rule is split up in the sense of, well, you'll see, but there might be two formulas provided, and which formula you need to use is going to be clarified in the problem itself. So, how about this question? So, given f of x equals two formulas, either x squared plus 10, or the second piece is the formula root x minus 3, but which piece should you use? Well, use the first part, use x squared plus 10 if x is less than 3, and use the second piece if x is greater than or equal to 3. And let's find f of 1, and f of 2, and f of 3, and f of 4, and f of 5. So what about finding f of 1? Well, 1, so 1 takes the role of x right here, and x less than 3, that's what's being satisfied right now. So we only look at x squared plus 10, and we compute 1 squared plus 10 is 11. F of 2, so now 2 here in the parentheses plays the role of x, and so we still have x is less than 3, so we use this top piece and plug in 2 for x and have 2 squared plus 10, which is 14. F of 3, well, now 3, the number in parentheses is x less than, so is x less than 3? That's no longer satisfied. 3 is not less than 3. Instead, we have x is greater than or equal to 3. So we plug in 3 for x into the bottom formula. We have root 3 minus 3. In other words, we have root 0. And by the way, root 0, just like a little earlier, is equal to 0. So do not compute 3 squared plus 10. That's irrelevant for the problem. F of 4. Now 4 is x, so x is greater than or equal to 3. That part is satisfied. So we have root 4 minus 3. In other words, we have root 1, which is equal to 1. And then then f of 5. So 5 is x, so x greater than or equal to 3 is satisfied. We should look at this bottom piece. So we have root 5 minus 3. Don't distribute the radical. That's made up when you have a minus sign. Instead, we just simplify inside the radical. So we have a root 2. And we'll just stop there because root 2 doesn't simplify further by hand. Okay, the clarification I want to make, this is not two functions. This is one function. The function is f of x. It's just it has two pieces. It's one piecewise function. So there's a piece called x squared plus 10, and there's another piece which is root x minus 3. Those two pieces together make the one function. And this one function, we looked at the input 1 and found the output is 11. Again, with the same function, with the input 4, we found the output is 1. Let's try another. Okay, yeah, let's see. Oh, yes, let's clarify this. I think it was said, but just to make sure it's in the slides as well. Which piece do you use? Well, to slow down here, to find f of 5, I mean, we already did it, but just to talk about it, to find f of 5, notice that x is 5. The input is 5. And so the part that's true, is it x less than 3 is true, or is it x greater than or equal to 3 is true? Well, it was x is greater than or equal to 3 is true. And so because of that, we followed this piece. We ended up using the root x minus 3 piece, and we did not look at the x squared plus 10 piece at all when finding f of 5. Okay, let's look at another example. Ooh, here's a function, but this is not a function in two pieces. This is a function in 3 pieces. I see another typo, so I'm going to correct this in just a moment here. All right, so the 3 pieces here are 3x, and then x minus 1, and then x over 2. And which piece you use depends on the text that you see here. So, for this one function, this what's called a piecewise function, which has 3 pieces, let's find g of 10, let's find g of 2, and then let's find g of 24. Ooh, all right. So, g of 10, okay, so 10 satisfies, so if 10 is x, that satisfies being between 8 and 20, so we should use this piece. So 10 minus 1 and get 9. G of 2, well, 2 being x now satisfies x is less than 8, so we use this piece. We have 3 times 2, which is equal to 6. Ooh, this shouldn't be a minus sign, that should be an equal sign. And then finally, g of 24, now let's put in the corrections here. Okay, to find g of 24, 24 is now x, and so which is satisfied? Is it x is less than 8? Is it 8 is less than or equal to x is less than 20? Or is it 20 is less than x? Well, it's 20 is less than x. So we follow this third piece that says x over 2. We plug in 24 for x there. 24 over 2 is equal to 12. interactive question. Now, okay, the problem up here is done, but given the function above, when asked g of 4, somebody wrote down g of 4 equals 3 times 4 plus quantity 4 minus 1 plus 4 over 2, which is simplified to 17. Explain what they did wrong and what they should do instead. Okay, we're going to end on this thing called average rate of change. What it looks like looks a little strange, f of a plus h minus f of a all over h. But let's just go through an example and say, don't overthink it. We have actually seen a lot of the little pieces. We just need to put pieces we've seen together. So, just diving into this example, if f of x equals x squared, let's find f of a plus h minus f of a all over h. By the way, let's mention that f of a plus h is not equal to f of a plus f of h. So you cannot just distribute a function like this. You just need to compute based on what you have. So just to recall some things, just let's be as consistent as possible with the notation. I mean, we have f of x is equal to x squared, so f of 3 is equal to 3 squared. So f of 3 plus h should be 3 plus h squared. Right? So we replace every x with what you have in parentheses. So that's just, this is not, wasn't asked in the question, but I just wanted to friendly reminder of how this works. And so to find f of a plus h minus f of a all over h, fortunately this minus sign, where it's located, separates two mini problems. There's the f of a plus h problem, and then there's the f of a problem. And we just do those separately. So f of a plus h, that, if you replace every x with an a plus h, you have a plus h quantity squared, and then copy the minus sign, and then you have f of a. Well, if you replace every x with an a, you have a squared. So, okay, so after the minus sign was an f of a, that has now been replaced with a squared. That's still just all over h. There was no f down there, so we just leave that alone. In the numerator, we can FOIL this out. You know, a plus h times a plus h is going to become a squared plus 2ah plus h squared, and still copy the minus a squared that was there all over h. Now you'll notice the numerator, a squared minus a squared, will simplify. So we end up with 2ah plus h squared all over h. Now this h cannot cancel with this h, because the h here in the numerator is not a factor due to this plus sign. But notice in the numerator, we could rewrite the numerator by factoring out an h. So the numerator could be h times the quantity 2a plus h. This is still all over an h in the denominator. Now that we have h as factors both on top and bottom, we can cancel and be left with 2a plus h.